So now that you know how to find surface area of prisms and cylinders individually, what we're going to do now is practice putting them together and finding the surface area of composite figures. We did area of composite figures, so this is very similar, except for now, of course, we're talking about three-dimensional figures, and we're talking about surface area. So it says, find the surface area of the composite figure. So first we need to recall, what is surface area? Surface area is all of the area that is visible, okay? So for example, I like to think of it like all the area that you could paint, right? So if I look at this figure right over here, now if I was going to take a paintbrush to it, I would paint here, I would paint this right side, I would paint that bottom, I would paint that back side, which I can't see all of it. I would paint that left side, and I would paint the top. Of course, I'd paint that cylinder and the top of that cylinder as well. But notice that as I'm painting, that cylinder on top of the prism intersects at that circle, right? And that circle does not get painted. So I need to keep that in mind as I am creating my skeleton of my formula, right? So I'm going to say surface area equals, let's talk about the prism first. I want to take the surface area of the prism, but I want to subtract off that circle that's at the top that's being covered by the cylinder. Okay. And then to that, I want to add on the surface area of that cylinder, okay? But again, I want to take off that bottom base. You can do this one of two ways. You can say surface area of the cylinder minus the circle at the bottom. Or you can say, let me just go find lateral area. That just gets me that curved figure and add on a circle. You can do it either way. Those are both going to be equivalent statements, whether I take the full cylinder and subtract a circle, or I take just the lateral area and I add a circle. So let me go ahead and do lateral area and add the circle. So lateral area of the cylinder and add on area of a circle. Okay, so that right there is the skeleton of my surface area formula. Now I just have to go substitute in the values. Now let me remind myself what the formula for surface area of a prism is, and that formula is perimeter of the base times the height plus 2 times the area of the base. I'm going to subtract off the area of a circle, which is pi r squared. And then I want to add on lateral area of the cylinder, which the formula is 2 pi r h. And then I want to go add on the area of a circle, which is pi r squared. Now, before you even start substituting anything, you might realize, hey, I have a negative pi r squared and a positive pi r squared. Those, of course, when I substitute in values, are going to subtract out. They're going to cancel each other out. So now all I'm left with is ph plus 2b plus 2 pi rh. So let's go substitute those values in. So again, this is the prism that I'm talking about. So I want to take the perimeter of the prism, so of the base of the prism. So that's going to be this shape right over here, which of course is a rectangular prism. So it is going to be perimeter is equal to 2 times 9 plus 2 times 4. 2 times 9 is 18. 2 times 4 is 8. 18 plus 8 is 26. Times the height of the prism, that of course is this 5 right over here, plus 2 times the area of the base. So let me come over to the side and go find the area of the base, which is 9 times 4. So that's 2 times 9 times 4, of course, is 36. Okay, now I'm going to deal with the cylinder. So let's do plus 2 pi. My radius is 2. Oh, how nice. They gave us the radius instead of us having to divide the diameter by 2. And then, of course, the height of the cylinder is this 3 right over here. And then all I have to do is simplify. It does not tell me to round, so that means my final answer is going to be in terms of pi. So I'm going to say equals 26 times 5 is 130. plus 2 times 36 is 72 plus 2 times 2 is 4, 4 times 3 is 12, so that's 12 pi. Now, I cannot combine something that has pi with something that does not have pi, but I can combine this 130 and this 72. 130 plus 72 is 202. And that's going to be my surface area equals 202 plus 12 pi. Since I cannot combine those, centimeters squared, and that is my answer. The hard part here that a lot of people might find difficult is not necessarily the calculations, okay? It's to figure out this skeleton formula right over here to say, okay, what is actually visible or is able to be painted, which is how I like to think of it. Okay, we have 2 more examples. And on the next example, instead of us adding on to our prism, we're actually taking away from it. So let's take a look and see what happens. Okay, this says find the surface area of the composite figure, round to the nearest thousand. So if I look at that figure, it's pretty clear that there's a prism and then the cylinder has been cut out of that prism, right? So when I'm talking about the surface area, it's everything I'm able to paint. So I can obviously paint all of the outsides of that cylinder, of that prism. But if I look, I can actually go into the inside of that prism where the cylinder has been cut out and paint that curved area as well, okay? So my surface area formula, I'm going to start with the surface area of my prism. So I'm going to say surface area of the prism. But notice that on those two, that front end and that back end, a circle has been cut out of it on each side. So that means I need to subtract off 2 circles. So the area of 2 circles. So that takes care of the outside of that prism. Now I got to take care of that inside where that cylinder's been cut out. Now, I've already taken care of those 2 circles, right? So now I just need to talk about that curved part on the inside, which of course is also known as the lateral area. So now I'm going to add on the lateral area of the cylinder. And again, it's not a matter of actually doing those calculations. Where a lot of people struggle is creating this part right over here. So now I'm just going to go substitute in my formulas. Surface area of a prism is perimeter of the base times the height plus 2 times the area of the base minus 2 areas of the circle. So area of a circle is pi r squared, so 2 pi r squared. And I'm going to add on the lateral area of a cylinder, which is 2 pi r h. So now, of course, I need to find the perimeter of my base. Notice my base is actually a square, so this is actually going to be pretty easy for us to find that perimeter. 2.5 plus 2.5 plus 2.5 plus 2.5, which is 10. Times the height, which again is 2.5. Plus 2 times the area of the base. The area of the base, of course, is 2.5 times 2.5. Which is, just wanted to confirm, 6.25. Okay, minus 2 pi r squared. So now I'm talking about those circles that I'm cutting out. 2 pi, my radius is 0.75 squared. Now I want to add on 2 pi RH from that lateral area of the cylinder. So plus 2 pi 0.75, and my height is going to be from the front to the back, which is 2.5. And now all I have to do is simplify. Notice that this right here and this right here, both of those have pi, so I'm going to be able to combine those once I simplify, and then this doesn't. Now, that really only would matter if it did not allow us to round. This one does allow us to round, which is very nice. So once I simplify, I actually end up getting 37.5 plus 2.625 pi. And luckily for us, we can actually combine those on this problem because it says to round to the nearest thousandth. So all I have to do is type that into my calculator. And so my final answer would be surface area equals, well, let's not say equals, let's say approximately 45.747 millimeters squared. Okay, again, the calculations are not the difficult part. It's just being able to set up that skeleton for your formula to get substituted into. So we did one where we added, we did one where we had to subtract. So like one where it's two figures stacked and one where figures are cut out of one another. Let's now talk about how changing our dimensions changes the final answer. So it says the edge length of a cube is tripled. Describe the effect on surface area. So first of all, this is a cube, which tells me that this is also 8 centimeters, and this is also 8 centimeters. Okay, so now I can move on from there. Our job is to describe the effect on surface area if the edge length of the cube is tripled. So let me go first find the surface area on this cube. Same formula as before. Perimeter of the base times the height plus 2 times the area of the base. Perimeter of the base, of course, is going to be 8 plus 8 plus 8 plus 8, which is 32, times my height, which is 8, plus 2 times the area of the base, which is going to be 8 times 8, which is 64. So 2 times 64. Okay, so now I'm going to go and find that area, which is 384 centimeters squared. So that's my original surface area. Now imagine that I had the exact same figure. It's also a cube. However, this time the dimensions are different. Ooh, pretty good cube if I do say so myself. You might not, but that's okay. They're tripled, right? So 8 times 3 is 24. Again, 24 and 24. So now I got to go find the surface area of that figure right over there. Formulas don't change, just those values are going to change that we substitute in. Perimeter of the base times the height plus 2 times the area of the base. Perimeter of the base is 24 plus 24 plus 24 plus 24, which is 96, times the height, which is 24 again, plus 2 times the area of the base, which is 24 times 24, which is 576. And now I'm going to go simplify that. So that surface area is 3,456 centimeters squared. It didn't just say go find the surface area. It said describe the effect on the surface area. And the way that you figure out how something changed, to figure out that change, you are going to do new divided by old. Okay? So we're going to do 3,456 divided by 384. And when you simplify that, you'll get 9. So that tells me that the new surface area is 9 times the old surface area. And actually, there's something even more cool and more specific than that. Notice that it tells me that I tripled my edge length. And notice that the surface area got multiplied 9 times. I know that 3 squared is 9. And think about our dimensions on area. We always put centimeters squared, yards squared, millimeters squared, right? So it makes sense that when I take an edge length and I triple it, the effect on the area is that it squares by that multiple. So multiply by that factor squared. So that's it on that. Again, whenever you're finding those composite figure surface areas, you need to create that skeleton and then start substituting, and make sure you haven't accidentally left on any values or accidentally subtracted off something that needs to be there.